Yes.
Okay, so now what we are going to do, we are going to do the next calculations, which will be your empirical formula, okay, and which will be the main thing which we use for the calculations. That is like one atom is equal to Avogadro's number. That all calculations, inshallah, we will do today, and then your last thing will be percentage purity. Then your formula chapter will be done. Okay. Let us start with this.
Yes.
Okay. So now do remember one thing, that whenever you find the relative molecular mass, find relative molecular mass, that was what we find it by what? How do we find relative molecular mass? If I am having H2SO2, that was that we are finding the masses from periodic table and we are doing this, isn't it?
By the volume divided
By the masses, like see H2SO4, how to find the relative molecular mass? We were having the mass from the periodic table. Hydrogen 1 multiplied by 2 plus sulfur 32 plus 16 multiplied by 4. This is how you find the molecular mass. Now do remember, whenever you find the molecular mass, okay, whenever you find the molecular mass, we relate that molecular mass to 1/12 mass of a carbon. Okay, we
Yes.
relate molecular mass to 1/12 of mass of carbon. Okay, we relate this to 1/12 of mass of carbon. Now, the question is that if you are having, or if you want to find the moles or number of moles of an atom, okay, of an atom or of an ion, how you are going to do that? How you are going to find the number of moles of an atom or an ion? Do remember, whenever you want to find the number of moles of an atom or of an ion, what, or of a molecule, what we are for an atom first we will do, then we will go on an atom. Whenever you want to find the number of moles of an atom, you have to use the formula as number of atoms divided by Avogadro's number. This is called as Avogadro's number. Whenever you want to find the moles, basically the moles of an atom or a particles, you have to do what? You have to divide it by Avogadro's number. This is called as Avogadro's number. Okay, now let us see one question. I'm writing a question as how many moles of neon contains 1 into 10 raised to power 23 neon atoms. Now you have to find number of moles. What formula are you going to apply? You are going to apply atoms, basically mean that you are going to apply this formula. The number of moles of an atom is equal to, this is neon atom given, 1 into 10 raised to power 20
Yes.
divided by Avogadro's number, which is 6.023 into 10 raised to power 23. Got this or no?
Yes, got it.
Got it? So now calculate and tell me the answer. Then I will change the question. अभी नहीं करना. What the answer?
0.166.
Okay. 0.167. 66 or 67 minutes. Now I'm changing the question because 3 types of question basically come from this. Okay, you just have to memorize this formula. One question is how many iron atoms are there? In 0.5 moles of iron. Now what we are going to do? Now what you have to find? Number of atoms?
Iron atoms.
Number of atoms. Number of atoms. Same formula. It will be moles of atoms is equal to number of atoms divided by Avogadro's number, which is 6.023 into 10 raised to power 23, isn't it? So now what is given
Yes.
in this formula? We are given with the moles and we have to calculate
Yes.
this. So that means 0.5 is equal to number of atoms divided by 6.023 into 10 raised to power 23, which is going to multiply by 0.5 into 6.023 into 10 raised to power 23. This will be number of atoms. Got it? How to do? Either
Yes,
you
got
will
it.
be finding the moles or you will be finding the number of atoms. But down thing will remain.
Right.
Okay. So whenever you are asked to find the number of atoms, you are going to use this formula. Okay, now the next
All right,
question
got it.
is when we are going to use the molecules basically. Now, what is the number? I'm writing the question. What is the number of hydrogen molecules? Not atom. Atom means single. Atom means single, like argon is a single thing, like silver is a single thing, iron is a single thing. These are atoms. Now we are
Right.
talking about molecules. What does molecules mean? Molecules mean double. Either they will be in
Yes.
H2 form like this one. These are the molecules. These are the molecules. So now what we are going to do, we are going to find the number of, what is the number of hydrogen molecules, and question 2 will be hydrogen atom in 3 moles. 2 questions we have to do. What is the number of hydrogen gas? Number of hydrogen gas. What is the number of hydrogen?
1.
Okay, so now what we are going to do first? You have to find the number of molecules. How to find
So
number
it's like,
of molecules?
we need to multiply 1 into 2.
Yeah, you will be multiplying what? You will be multiplying 1 into 3. So what you will be getting? You will multiply this by what? Number of atoms you have to find, a number of hydrogen gas. So that mean the number of hydrogen gas mean hydrogen molecule. So number of atom is equal to 3 into 6 into 10 raised to power 23 or 6.023 6.023 into 10 raised to power 23. Isn't it? This will be in this form.
Wait, can you tell me how is you're multiplying 3 into 6.03?
See, see again. See, moles is equal to number of moles of an atom is equal to what? Number of atoms, number of particles, number of molecules, number of atom. It can be particle, it can be molecule, divided by 6.023 into 10 raised to power 23. Got it? So what is the number of moles given? See, hydrogen atom is 3 moles. So what is the number of moles given? Yes, Faiza. What is the number of moles given? It's 3, na? So 3 over here. See, it will be number of atom or molecule, both the same thing, divided by 6.0.
Can you just wait for a second?
Yeah, okay.
Sorry, there's someone at the door. That's
Yeah, no problem. You can go and come. So what we were talking about, you can have the number of atoms, you can have the number of ions, that you can have the word as number of molecules. It doesn't matter. Okay? Either examiner can ask you with the number of atom, either examiner can tell you to find number of molecules, or sometime examiner ask you to find number of ions. Okay, they mean the same thing. Moles will be here, the Avogadro's number will be here, you will get multiply these two. So when you will multiply these two, you are going to get number of atoms or number of molecules. So that means 3 multiplied by 6.023 into 10 raised to power 23 will be the number of H2 molecule. Got it or no?
yes, got it.
Okay, so now the next thing. Now see, this is for one molecule. This is for one molecule. Now we are having, basically they are asking if you are having, see, hydrogen atom in 3 moles. Hydrogen atom now they are asking. Hydrogen atom. First this was molecule.
Right.
Now number of hydrogen atom. So that means hydrogen atom will be equal to what? It will be equal to number of moles multiplied by Avogadro's number. Isn't it? Number of moles I brought on this side, and a number of atoms I have put on that side. So the number of moles for an atom is given as what? Is given as 3, isn't it? The moles which we use.
Yes.
So this moles is just for one atom, for one hydrogen.
Okay.
How many hydrogen do we have? We are having a molecule of hydrogen, which is H2. So that means how many moles are we going to use?
6.
6. Yes. So that means one atom, if this is 3, so 2 molecules will be 6. So now you are going to use number of moles as 6 multiply by 0.023 into 10 raised to power 23. So let me know the answer.
Three point six one into 10 to raised to power 24.
Okay, it's coming as 3.6. Yeah, 3.61 to 10 raised to power 24. Okay, this is correct. Got this? Understood?
Yes, got it.
Okay. So now we will
Yes.
move on to the next thing, which is finding of empirical formula and finding of molecular formula. How to calculate empirical and how to calculate molecular formula. Empirical and molecular formula. Now, how to do this? Okay. Let me have some, I just want some questions to be done. Just give me 1 second. I just want to open. Okay. So now what we were doing to find empirical and molecular formula. Okay. Let's suppose that I am writing a formula as C6H12O6. Simplify it. Go to the least ratio.
Which is carbon and oxygen.
For carbon, hydrogen, oxygen. Give the least number where these number cannot be further divided. Make this number very small.
Like, there will be one.
Yeah, okay. Make it
1 to 1. Small. That's how.
Yeah, that's how. Make the number very small in such a way that these numbers 6, 12 and 6 cannot be further divided into. Make the smaller number.
One to 1.
Okay, this will be CH2O, isn't it? Okay, now see this one. This is what this is called as simplest. We called it as simplest ratio. Or we called it as least ratio.
Right.
Least ratio mean now the number cannot be further subdivided. So whenever you are getting a least ratio, we call it as empirical formula. Got it or no?
Yes.
Whenever you are having a smaller number, what do we call them? We call it as empirical formula. This one, the complete formula, we called it as molecular or molecular formula. Okay. The complete one is called
Yes.
as your molecular formula. The least ratio or the simplest ratio will be called as your empirical formula. Now, these two things has to be done in calculation. You have to basically do calculation for this. How to do calculation? Let's suppose that I want to find the empirical formula. I'm not writing the complete empirical formula. I am just writing EF, which mean empirical formula. Okay. Let's
Okay.
suppose that I want to find the empirical
Yes.
formula of magnesium oxide. And I am given with the mass of magnesium as 1.20 and of oxygen as 0.80. So to find the empirical formula, the very first step you have to do, you have to find the moles. Find the moles first. So how to find the moles? Let me know. How do we find the moles? Yes, Faiza, how do we find the moles? What is the formula for moles we are using? Moles is equal to?
The mass divided by molar mass.
Very good. Excellent. It will be mass divided by molar mass. Mass is given. So that means 1.20.
Yes.
Molar mass of magnesium from periodic table. Let me know what is the magnesium molar mass from periodic table.
Yeah, is it 24?
Yeah, what is it? 24. Yes, okay. Now, what for oxygen? Oxygen is 0.80 divided by what?
16.
10. Now tell me the moles. Tell me the number of moles which are coming for both.
For magnesium, we got 0.05.
Okay, 0.05. Okay. And for
For oxygen, we're getting 0.05.
0.05. Okay. Now see over here we are having the same ratios. Okay. We are not having the different number. Okay. Let's suppose that if in case one of this was having a lowest ratio as 0.02. So now this is smaller and this is bigger, isn't it?
Yes.
So if this thing comes, if this thing comes that one is the smaller one molar value is smaller one, and one is the bigger one, then what you do, you take mole ratio. What is mole ratio? Divide moles, basically divide moles by smaller moles value. Got it? So first step, what we
Yes.
did, we found mole ratio. Second step, to find empirical formula, what we have to do, we have to find mole ratio. And how to find mole ratio? We have to divide the moles which we have calculated by the smaller number of moles. Over here we are having the same. So that means we will divide both by 0.05 in this way. So you will be having the values as 1 and 1. Isn't it?
Yes.
So we'll be having the value of 1, 1, 1. That means your formula, empirical formula will be MgO, magnesium oxide. Got it?
Yes.
Let us do one more. Now this is, you are going to calculate. I am just giving you 5 minutes. Okay, we are having the percentage of carbon, which is 49.5%, percentage of hydrogen, which is coming as 5.1%, percentage of oxygen, which is coming as 16.5. Now do remember, sometime examiner gives you the mass, okay, in grams. Sometime examiner gives you the percentage. So do use the percentage as mass. Okay?
Yes.
Whatever percentage will be given, what you are going to do, you are going to use that percentage as the mass. So now the very first step, we have to find basically empirical formula. So the very first step, what we are going to do, we are going to find
Molar mass.
we will be finding the moles. Moles of carbon, moles of hydrogen, moles of oxygen. So that means 49.5 divided by what is the molar mass of carbon? From periodic table.
Is it 12?
Yes, it is 12. Hydrogen is 1, oxygen is 16. So calculate what is the moles coming for all of these.
For carbon, I got 4.125.
Okay, 4.125. Okay. Next one.
And for the, yes, for the hydrogen one, it's same 5.1.
Okay. And for 16.5 divided by 16,
1.03.
1.03. Now tell me the next step. We have to find mole ratio, isn't it? So how to find mole ratio? First step moles, second step mole ratio. How to find mole ratio now? We will divide all the values by
The smallest number.
the smallest number. What is the smallest number over here?
1.03.
Okay. So 1.03, 1.03, 1.03. So tell me what the answers are coming.
For the first one, it's 4.
Okay. For the second one,
And for the second one is 4.95.
so that means it's 5 basically. And this is 1. Isn't it?
Yes.
So now what will be your formula?
Yes.
It will be C4H5O. This is your empirical formula. Got it or no?
Yes, got it.
So to do empirical formula, we will do 2 steps. First step is to find the moles first. Second step is to find the mole ratio. Then you are going to get empirical formula.
Great.
Okay, one more. Let us do one more.
Yes.
This you are going to do, then we will do the empirical formula. Carbon, hydrogen, oxygen. Carbon with the mass of 39.1. Hydrogen with the mass of 8.7. Oxygen with the mass of 52.8. Find empirical formula. Calculate. Let me know the
Okay. Matt, is it C1, H3, and oxygen 1?
Oxygen is coming as 1. Okay.
Yes.
What about hydrogen?
Hydrogen, I got the value as like 2.6. So is it hydrogen 3?
Hydrogen 3, okay. And what about the
So
carbon?
carbon, I got it's 1.
It's 1. So that means we will be having a formula as CH3O, isn't it?
1.
You got the same formula? You just told me, na?
Yes.
Okay. So this is your empirical
Yeah.
formula. Got it? Okay. Now we are going to move toward the next step of this.
Yes.
That is called as molecular formula. Okay. Now how to find molecular formula? To calculate molecular formula, do remember that you will be given with the mass. You will be given basically with the mass or weight. That let's suppose the mass over here. The mass of glycerol is 92.0 grams. Now you are given with the mass. So now what formula to find molecular formula you are going to use? You are going to use the number of, you are going to use the formula, whatever you have the mass given. So the mass given divided by empirical formula mass. What does this mean? This means whatever formula you made for empirical formula, whatever you have the empirical formula with you, you have to find the
Okay.
MR of this one.